Training an AI is one of the biggest challenges in the entire field. It's massively expensive, it's incredibly time-consuming. But what if there was a better way? What if we could teach AI to learn more like we do, smarter, not just harder? Well, let's dive in.
And that really is the million-dollar question, isn't it? We don't just want to cram AI full of data. We want to teach it how to reason, how to solve problems, how to actually improve on its own. For a long, long time, this has been a total brute force effort, but some brand new research is starting to change the game. You see, here's the thing. When we're building these powerful AI, we're caught in this fundamental trade-off. It's this constant balancing act between two goals that are always fighting each other, and it's created a huge bottleneck for all of us. So this is the core tension right here. On one hand, we're all chasing that peak performance, right? We want smarter, more capable models that can tackle really complex problems. But on the other hand, the computational cost, it's just astronomical. We're talking massive amounts of energy, time, and money, and that has really slowed down progress. Okay, so to really get why this new breakthrough is such a big deal, we have to take a quick look at the old way of doing things. The last generation of training methods, well, they had a really big problem. They were essentially learning without a compass. These are called critic-free methods, and a great example is one called GRPO. Now, the idea here is that the AI makes a whole bunch of attempts at a problem, but instead of an external teacher or a critic telling it how it did, it just grades its own attempts by comparing them to each other. Think of it like a sports team watching its own game tape and grading itself. And the process is pretty straightforward. The AI generates a bunch of different solutions. Then it calculates the average score for that whole group, and finally, it judges each individual attempts against that average. But here's the problem. That average is constantly changing with every new batch of attempts. The standard for what's good is always a moving target. And that right there, that brings us to the crucial flaw. The AI can get completely trapped in what's called a local optimum because it's only comparing itself to its own recent, very similar attempts. It can start to think it's doing an amazing job. It gets stuck in a rut, completely blind to the fact that a totally different and much, much better solution even exists. This is where the new research comes in, proposing a much, much smarter way for AI to learn. It's a breakthrough method, and it's called Pvpo, which stands for Pre-Estimated Value-Based Policy Optimization. The core idea is actually inspired by us, by how humans learn. Think about it. We don't just compare what we're doing now to what we did 5 minutes ago. We often use a fixed benchmark, a stable reference anchor, to judge our progress. It's just a way more stable and efficient way to get better. And that's exactly what Pvpo does. It stops the AI from grading its own homework on this crazy shifting curve. Instead, it gives the AI a stable answer key, a fixed reference point to use. And this seemingly simple shift, well, it changes absolutely everything. So how does it pull this off? Pvpo's success really comes down to two incredibly clever innovations. I like to call them its two secret weapons.
All right, secret weapon number one is the static anchor. Unlike the old method's constantly fluctuating dynamic baseline, which is super unstable, Pvpo uses a fixed, reliable baseline. It doesn't change with every single attempt, and that provides a clear, consistent direction for the AI to learn.
And that brings us to secret weapon number two, which is just a brilliant technique called group sampling. The best way to think about this is as smart practice. Instead of just having the AI blindly work on every single problem, Pvpo intelligently filters the data so it can focus its efforts where they'll have the most impact. So check this out. Here's how that smart practice actually works. Pvpo basically sorts all the training problems into 3 piles. It completely filters out the easy ones. No point in wasting time. It focuses on the ones that are just right for learning. And for the almost 50% of problems that are too hard, well, it does something really clever. So what about those really tough problems where the AI just gets completely stuck? This part is genius. Pvpo basically calls in for backup. It brings in a larger, more powerful model to generate a perfect solution, a perfect example. This is called a ground truth trajectory, and it gives the AI a clear roadmap of success to learn from, which avoids tons of wasted effort. Okay, so the theory is fantastic, right? But does it actually work in the real world? Let's get to the results, because this is where things get really staggering. So get this.
When they tested it on these really complex multi-step reasoning tasks, the 7 billion parameter model trained with Pvpo doesn't just crush the old GRPO method, it actually starts outperforming much, much larger models, like Gemini 2.5 Pro, on these specific tasks. A smaller, more efficiently trained model is beating the giants.
And it's not just better, it's way, way faster. PvPO achieved the same level of performance as the older method in half the training time. That's a 2 times speed up. The efficiency gains here are just massive. Even when running on a low budget, PvPO achieves 97% of the older method's peak performance while using less than 40% of the computational cost. That is an incredible leap forward. Okay, so the tech is impressive, the numbers are incredible, but what does all of this mean for the big picture? Why does making AI training more efficient matter so much for the future of AI?
This is an absolute game changer. It means we can build more powerful, more specialized AI with way fewer resources. It's essentially democratizing AI development. We can unlock complex reasoning in smaller, more accessible models, and we can accelerate cutting-edge capabilities like agentic search and AI tool use. Ultimately, by teaching AI to learn smarter, not just harder, we're knocking down one of the biggest roadblocks to progress. And it leaves us with this huge, exciting question. With the ability to develop these advanced AI capabilities so much more efficiently, what new, once unsolvable problems will AI be able to tackle next?